Morning, everyone. Hope you're all well today. So, as you'll already know, I'm actually not in the classroom today. You have this summer, but you were still going to be doing work. So, as of now, you should all have a worksheet in front of you. So, how today is going to work is that I will go through this video. I will ask Miss Summers to stop the video at certain points. Then you will complete an activity, and you'll come back to the video again once you have that activity complete. So today we're going to be looking at the human interaction with the rock cycle and how humans exploit rocks for the good of their own use. So there's that whether that be building materials or turning rocks into energy that we can use as like heat energy, hot water, etc. So one way we're going to look at doing this today is through geothermal energy. Now, many of us will have already heard about geothermal energy. We looked at it in our first couple of chapters on volcanic activity. You will have heard about it for your junior cycle as well. So our learning intentions for today are to define, by the end of this class, we want to be able to define what geothermal energy means. We want to understand how geothermal energy is being produced, and we want to understand the uses for geothermal energy. So if you look at the very top of your worksheet, you'll see that I have these learning intentions laid out for you. So what we will do is, as we go through the activities today, when you complete an activity, we'll go back and we'll tick off the learning intention once you feel like you can do what is being asked of you. So the first little activity I want you to do today is open up your copy, and I want you to create a definition for what you think geothermal energy is. As I've already said, that we have looked at geothermal energy earlier on in the year, and we looked at it through volcanic activity and like the formations of mid-ocean ridges and volcanic mountains. You may have also looked at it as well in your junior cycle study. So I'm going to give you 2 minutes now to create a definition in your copy for geothermal energy, and then we'll come back and I'll give you the official definition for it. If someone will pause the video here. Okay, so geothermal energy is heat energy captured from hot rocks in the Earth's crust. You'll see that there in front of you, okay? So geothermal energy involves the use of volcanic activity. So geothermal energy is heat energy captured from hot rocks in the Earth's crust. So as you will know, the closer the crust gets to the mantle, or the further we dig down in our crust, the hotter the rock becomes. So when we dig down about 1 kilometre down into the crust of our Earth, the rocks are super hot. They reach about 280 degrees Celsius to 300 degrees Celsius. So what we do is we use these hot rocks to therefore heat water, which then generates geothermal energy. We're going to look at that in a few minutes' time on how exactly we capture and produce geothermal energy. But for now, I want you to look to use activity 1 on your sheet. And I want you to just fill in the blanks on the definition. So on your handout, I created a definition for geothermal energy. Please just fill in the blanks in the definition. So I've just given you the definition, which is geothermal energy is heat energy captured from hot rocks in the Earth's crust. Okay, so we all know that the crust of the Earth is the outside layer of the Earth that is made of solid rock. Okay, so we stand on the crust of the Earth. What we stand outside is the crust of the Earth. So I just want you to fill in the blanks in that definition. On the first part of your sheet, you have 30 seconds to do that. So again, if someone will just pause the video here, I will put it back on after once you have it filled in. Okay, so at this stage, you should all have geothermal energy is heat energy captured from hot rocks in the Earth's crust. That's what you should have written in them blanks, okay? If you have that and you reckon you could rewrite a definition for geothermal energy, I want you to go back up, tick the learning intention at the very start that says we want to be able to define what geothermal energy is. So our official definition for geothermal energy is heat energy captured from hot rocks in the Earth's crust. Geothermal energy in Iceland. We're going to use Iceland as our example of a country that uses geothermal energy. However, it isn't the only country that now uses geothermal energy. There is other countries doing it as well, such as the USA. Later on, we will look at comparing these. So the first thing I want to do is define Iceland's location in relation to plate tectonics. So Iceland is one of the major producers of geothermal energy. They are the pilots for geothermal energy, and they've been producing geothermal energy since the 1930s. Because of its location on the mid-Atlantic ridge, okay, so Iceland is located between America and Ireland, okay, so it's located right in the middle of the Atlantic Ocean. and it's along the mid-Atlantic ridge, which is where the North American plate and Eurasian plate are separated from each other. It's a constructive plate boundary, so there's plenty of volcanic activity happening there. Okay, so the volcanic activity is quite close to the Earth's surface. In Iceland, the active volcanic zone stretches through the country from southwest to northeast. Okay, forming hot igneous rocks that is used to make geothermal energy. So we should know now from earlier on the chapter that igneous rocks are created from volcanic activity. So Iceland have now taken these hot igneous rocks and are using them to create geothermal energy. Okay, geothermal energy is a renewable resource. We're not going to run out of it anytime soon. We're not burning fossil fuels. We're not releasing CO2 into the air. We're using volcanic activity. So we're using the hot rocks that are created from volcanic activity to create geothermal energy. So you need to know that Iceland is one of the major producers of geothermal energy. It's the pilot of geothermal energy. It's been producing geothermal energy since the 1930s. It's located on the mid-Atlantic ridge. It's located right in the middle of the Atlantic Ocean, where the North American plate and the Eurasian plate are separating, creating a constructive plate boundary. You will know what a constructive plate boundary is from your study of volcanic activity. And we need to know that in Iceland, the active volcanic zone stretches through the country from southwest to northeast, forming hot igneous rocks that is used to make geothermal energy. Okay, so I'm going to get you to complete an activity on this there now. Activity 2 on your worksheet. You need to write a paragraph in the box provided and explaining Iceland's location in relation to plate tectonics. Make sure to mention the two plates. Make sure to mention the two plates located on and the impact it has on our Iceland's volcanic activity. You can use the map to help you with your explanation. So I provided this map here on your worksheet. So use that map to help you create an explanation of Iceland's location in relation to plate tectonics and volcanic activity. I am going to get you to 3 minutes to do this activity. So Miss Summers is going to pause the video now when I finish talking. You're going to have 3 minutes to do this activity, and then we'll come back and make sure you have it written down correctly. So Miss Summers can pause the video here now. Okay. So you should have something along the lines of Iceland is a major producer of geothermal energy. It is located in the mid-Atlantic Ocean, where the North American plate separates from the Eurasian plate along a constructive plate boundary. This forms an active volcanic zone. In Iceland, the active volcanic zone stretches through the country from southwest to northeast, forming hot igneous rocks that are then used to make geothermal energy. So something along them lines, have as many key points present as possible. And if you don't have all them key points, make sure you add them in. Okay, so we need to have mid-Atlantic ridge, we need to have North American plate, you need to have Eurasian plate, you need to have constructive plate boundary and volcanic activity. Preferably also have that it's the volcanic zone in Iceland stretches from the southwest to northeast. Okay, so how is geothermal energy produced? What we do in geothermal energy, when it rains precipitation or snow, when it rains or snows, what happens is this precipitation seeps down through the bedrock. Okay, so it seeps down through the bedrock on the Earth's crust into the Earth's crust about 1 kilometre. When it seeps down, that rock becomes hotter and hotter. Okay, so it reaches about 280 to 300 degrees Celsius. So you can think about that water, when it hits the hot rock, it instantly heats up. And the cold water that fell on the Earth's crust has now instantly became hot. So what Iceland have done is they've drilled down into the crust of the Earth and extracted this hot water. However, natural precipitation isn't always present. Okay, so there's not always rain, there's not always snow. And for that reason, they've also started to pump cold water down into the Earth's crust as well. Okay, so if there's no natural precipitation, no natural water present, where they pump cold water down into the crust of the Earth about 1 kilometre deep, where the hot rock then turns the cold water into hot water. This hot water, or steam even, is then pumped back up to the surface of the Earth. When it's pumped back up to the surface of the Earth, it's in power stations. Okay, so this might be my power station just here. And there's turbines within this power station. The steam from the hot water then turns the turbines to create energy. And this energy is pumped out to houses all across Iceland. And they then use the hot water as well as left over, and that's also pumped to houses across Iceland. Okay, so I'm going to look at each one of them now for you. Magma rises from the mantle, heats the ground to over 200 degrees Celsius. Okay, so magma down here, that was down in the mantle, rises closer to the crust, and it heats the rock to about 200 degrees Celsius. Water just 1 kilometre below the surface is in contact with very hot igneous rocks and becomes superheated. Then we need to remember that these are igneous rocks. Igneous rocks are created from volcanic activity. Therefore, this is a volcanic zone. This is igneous rocks. Number 3, then, wells are drilled into the ground to extract this hot water. Okay, if the area lacks a natural water supply, cold water is pumped into the ground to be heated naturally. Okay, so they either drill down to take the natural water out, or they're pumping cold water artificially down into the crust of the earth through these big wells. And then number 5, when the superheated water reaches the surface and the pressure is released, it turns to steam. That can turn large turbines and power stations to generate electricity. So when hot water is pumped back to the surface, a huge amount of pressure is left off. That lets off steam, and the steam then turns turbines within these power stations. These turbines, as they turn, are generating electricity, and that electricity is pumped out to homes all across Iceland. What I want you to do now is activity number 3 on your worksheet. Okay, so the first thing I want you to do is to rearrange the sentences by numbering them 1 to 5. So there's a series of sentences on the activity that are all jumbled up. I want you to rearrange these by labeling them 1 to 5. You've got 3 minutes to do that. You can then consult with the person closest to you to make sure you've got them correct. Make sure you're still at a 1 metre distance or 2 metre distance, and you have your masks on, please, for this. This someone will be watching us. So you can consult with the person next to you to make sure you've got it right and they've got it right. Consult with each other and rearrange them if necessary. You've got a minute to do that. And the last thing I want you to do, I'm going to give you 6 minutes to do this, is to write the sentences into your hardback under the heading, the production of geothermal energy. Okay, so once you rearrange the sentences, you and the person you're closest to are happy with the arrangement of them sentences, I want you to write them into your hardback under the title, the production of geothermal energy. You have 10 minutes to complete this activity. Miss Summers will pause the video here, give you 10 minutes to do it, and she'll put the video back on then once you have that complete. Okay, so at that stage, you should all have your written into your hardback the production of geothermal energy with your sentences labelled 1 to 5. The sentences should look like this. The first one should be magma rises from the mantle, heats the ground to over 200 degrees Celsius. Number 2, water just 1 kilometre below the surface is in contact with very hot igneous rocks and becomes superheated. Number 3, wells are drilled into the ground to extract this hot water. Number 4, if the area lacks a natural water supply, cold water is pumped into the ground to be heated naturally. And 5, when the superheated water reaches the surface and the pressure is released, it turns to steam that can turn large turbines and power stations to generate electricity. You should have them 5 written out in that order into your hardback now. Okay. The last thing we're going to look at today is then the uses of geothermal energy. Now, geothermal energy can be used for a number. Can be used for a number of different things. So the first one is hot water, and I discussed this with you already. I've discussed how that once we've used the steam, the hot water that's left over from that steam is then also pumped to houses all across Iceland, and so to be used as a domestic use, such as showers, in showers and like washing your dishes, washing your clothes, etc. Once this hot water has been used in your domestic use, it can then be pumped to greenhouses. Okay, so we need to remember that Iceland's a very cold country, and therefore the growing season tends to be quite short. Okay, so the agricultural growing season tends to be quite short. This hot water is used to heat the soils in greenhouses, making their growing seasons much longer. Okay, so it helps with the production of fruits and vegetables. This hot water is also used in pavements and car parks in Iceland's larger cities such as Reykjavik. Okay, so it's used in the pavements and car parks to keep them ice-free during the winter, to keep them safer for pedestrians and commuters. And again, then agriculture, as I just said, the growing seasons in Iceland tend to be very short as it's such a cold country. Temperatures are so low that crops don't like to grow, so they can heat the soil using this hot water, which is much cheaper. than using oil to heat them up, which makes their growing seasons longer. They get higher crop yields. If they get higher crop yields, they make more money. They have more food supplies at a local source. Okay, so hot water. So hot water is pumped from the service or the energy stations to the houses and businesses, and that hot water then is recycled again into greenhouses to heat the soil. It can also be used in the pavements and car parks to keep them ice-free in the winter times, and then agriculture as well, lengthening our growing seasons, increasing our crop yields, making more money, more locally sourced fruit and vegetables. So our last activity today, lads, you need to complete activity number 4 on your worksheet, which is to fill in the blanks using the word bank given based on the use of geothermal energy. So I've created a paragraph on the bottom of your worksheet, activity number 4. There is a word bank at the bottom of that worksheet. You are to use the word bank to fill in the blanks on that worksheet. It should take you probably no more than 5 minutes, hopefully. So I'm going to give you 5 minutes to this activity. Miss Summers is going to stop the video here. I will be back to school tomorrow, and I will correct that fill in the blanks with you. We'll go over, we'll have a little recap on geothermal energy. But however, for your homework, I need you to read page 105 of your book. You're to use activity 5 on your worksheet to create 4 benefits and 4 positives to take from geothermal energy. So 4 positive effects of geothermal energy. So read through page 105 on your book, which is a case study of geothermal energy in Iceland, and take 5 positive effects from it. Okay, so please complete activity number 5 for your homework. Okay, homework then is to please complete activity number 5. I will see you all in class tomorrow.